Let's talk about a moment in time that completely changed the game for one of the world's biggest programming languages, Java. We're going back to 2014, to the release of Java 8. Why? Because this one update laid the groundwork for pretty much all modern Java development, and it did it by tackling one massive, annoying problem: verbosity.
So before Java 8 came along, if you wanted to do something as simple as run a bit of code in a new thread, you had to write, well, this. Look at it. This is called an anonymous inner class. You've got the new runnable, the public void run method. It's so much ceremony just to print hello world. This is what we call boilerplate code, and trust me, it was everywhere.
If you've ever had to work with older Java code, I bet you're nodding your head right now. It just feels clunky, right? Verbose. It can make a really simple idea feel super complicated to write out. The folks behind Java knew this was a huge pain point, and lucky for us, they were cooking up a pretty massive solution.
And that solution arrived with Java 8. But calling it just an update doesn't really do it justice. It was a full-blown revolution. It brought a completely new way of thinking about and writing code into the Java world, taking a big cue from a different programming style.
Essentially, Java, which had forever been this super strict object-oriented language, learned to speak a new language: functional programming. And what did that mean for developers like us? It meant we could suddenly write code that was way cleaner, way more concise, and honestly, a lot more powerful.
Now, the absolute star of this revolution, the feature that everyone talks about, is something called Lambda expressions. They are without a doubt the most important change in Java 8, and they directly attack that boilerplate problem we just saw.
And here you have it. The proof is right here. On the left, our old clunky friend, and on the right, the sleek new Java 8 way. All that ceremony, those 5 lines of code just compressed into a single beautiful line. The boilerplate just melts away, and all you're left with is the code that actually matters. That's the power of Lambdas.
So what exactly is a Lambda then? The easiest way to think about it is as an anonymous function. It's a little chunk of code that you can pass around and use wherever you want. The syntax is super simple. You've got your parameters on the left of the little arrow, and the code you want to run on the right. It's basically a function on the fly.
The benefits here are just huge. Your code gets shorter, which is great, but once you get the hang of it, it also gets way easier to read. You can focus on what you're trying to do, not the how of creating some new object. Lambdas are really the gateway to writing in that functional style right inside of Java.
Now, Lambdas are the tool, right? But the Stream API is where they really get to work. This was a brand new API that totally changed how developers handle collections of data. Think lists, sets, you name it, by using the power of those Lambdas we just talked about.
The best analogy for a stream is a data assembly line. Seriously, instead of writing messy for loops to go through a collection one by one, you just send your data down this pipeline of operations. Each step on the line does one specific thing, shaping and transforming the data as it flows past.
And this assembly line always has 3 parts. First, you need a source. You get your stream from a list or some other collection. Second, you apply what are called intermediate operations. These are your workstations, things like filtering out items you don't want or mapping each item into something new. And finally, you have a terminal operation, which is what actually produces your result, like a new list or just a final count.
Here are a few of the most common operations you'll see. Notice the type column. This is really important. Intermediate operations like filter and map are actually lazy. They don't do any work until a terminal operation gets called. It's the terminal operations, like for each or collect, that kick the whole assembly line into gear and give you your final product.
Okay, so Lambdas and streams were the huge headliners. But Java 8 also rolled out a bunch of other features that were all about making our code cleaner, safer, and just more modern by fixing some really old, nagging problems.
Ah, yes, the null pointer exception, otherwise known as the billion-dollar mistake. For decades, this has been the single most common and definitely the most hated error for Java developers, while Java 8 introduced a really clever way to fight back.
Say hello to optional. Think of it like a little box. That box might have something inside it, or it might be empty. And that's the whole point. Instead of passing around a value that might be null, you pass around this optional box. It forces you, the developer, to explicitly deal with the fact that the value might be missing.
An optional gives you this clean, safe toolkit for working with that box. Instead of writing messy, if value equals null, checks all of your code, you can just ask the box, .is present. You can give it a backup plan with .or else. Or, my favorite, you can tell it to run some code only if something is actually inside, using .if present. It makes your code's intention crystal clear and gets rid of all those defensive null checks.
Another really big deal was what happened to interfaces. Before Java 8, interfaces were just pure blueprints. They could only say what methods a class should have, not how they should work. Now, interfaces can have default methods with actual code inside them. This was a game changer for evolving APIs, because now library creators could add new methods to an interface without breaking every single piece of code that already used it.
And finally, we have to give a quick shout out to the new Date and Time API. The old date and calendar classes were, well, let's just say they were famously awful to work with. Java 8 replaced them with a clean, smart, and intuitive API that finally made handling dates and times in Java a pleasure instead of a punishment.
So you might be thinking, okay, that was 2014. We've had a ton of new Java versions since then. Why do we still care so much about Java 8? Well, because these features weren't just tacked on. They fundamentally changed the DNA of the language itself.
Here's what it all boils down to. These features are your modern Java toolkit. They aren't optional extras. Lambdas and streams are now the standard way to handle data. Optional is your best weapon against nulls. And these things are so foundational, so critical, that you simply cannot walk into a modern Java job interview without knowing them inside and out. It's non-negotiable.
At the end of the day, Java 8 gave us a more expressive, a safer, and a more efficient way to get our work done. It was the great leap forward that brought the language squarely into the modern age. So the only real question left is, how are these tools going to change the way that you write code?